Well, dear students, in this video, I will be explaining you light emitting diode (LED). Now, it is very common here. Early in the morning, I was teaching, and a student asked me, "Sir, how the light is emitted?" Actually, before understanding the action of this, you must understand how the light is emitted by any source of light. You know, light wave or electromagnetic wave. Light has wave character. It means it consists of oscillating electromagnetic field. I explained him very clearly that when we heat a material, it absorbs energy. Then how the energy is absorbed? In fact, that energy absorbed is taken by molecules or atoms, and different methods of taking energy are present there. The molecule or atoms may oscillate about their mean position, and also the electrons present inside atom or molecules gain energy and go to higher energy state. You have learned lot of physics and lot of chemistry that electron in the different cells or orbital taking energy from outside source go to higher state where they are unstable, and they return back. When they return back, they emit extra energy in the form of electromagnetic radiation. Though electromagnetic radiation may be heat radiation, may be visible light, may be ultraviolet, or even X-rays are also emitted the same way. We give energy. So now, initially you have seen filament bulb, then fluorescent light, and now we are using LEDs. LEDs are giving light us to at very low cost. A 12-watt LED is sufficient here. One LED 12 watt, another is 9 watt, and they are producing sufficient light here to see, to do every work in the room. Initially, bulb were emitting filament bulb, which were called also as incandescent source of light. Incandescent means on heating filament, that filament was emitting heat radiation along with visible light. A large amount of energy was radiated in the form of heat. That is why the light emitted by 100 watt bulb was less than the light emitted by 40 watt fluorescent tube. Fluorescent tube has gas inside this, whose molecules get excited when we apply potential difference across electrode, and those excited molecules again return back to lower energy state by emitting energy. That energy might be in the form of visible light and ultraviolet radiation. Those ultraviolet were absorbed by the material painted inside the tube. Now LED is totally different. It works again on the energy gap between valence band and conduction band. So first of all, let us know what is light emitting diode. Light emitting diode. Once there was question in the board exam, and we found nobody was able to write what is light emitting diode. Some wrote LED, it is LED. But what is LED? The abbreviation to light emitting diode. But what is that? Simply it is PN junction, which have been obtained or manufactured by having higher dopant concentration. So in simple word we can write light emitting diode is heavily doped PN junction. hybrid or PN junction. When it is forwardly biased, it emits light spontaneously. Actually, this word spontaneously has been used here by me and by books knowingly. We can simply say that it emits light. But what is the meaning of spontaneous emission? Actually, when electron go to higher energy state, then they return back to lower energy state themselves, है ना, वो अपने आप ही हायर एनर्जी से लोअर एनर्जी में आएंगे. एंड व्हेन द इलेक्ट्रॉन कम फ्रॉम हायर एनर्जी स्टेट टू लोअर एनर्जी स्टेट, so they emit extra energy. So that is called spontaneous emission. Now there is one stimulated emission which is done in laser. There are laser diode also. Previously they were in syllabus. Now they have been removed to reduce the bulk of syllabus. So if the electron excited to high energy level, they will return back when we do something. That is called stimulated. So LED emits light when forwardly biased. White emits light in forwardly bias. A critical forward bias is given to this. So you see, an electric field applied across, there is one junction field. We apply electric field here. Due to forward biasing, hole go from valence band to conduction band. An electron go from actually can flow this way, so electron goes this way. So reverse bias current flows. So here number of holes increases, number of electron increases here, but the diode does not allow to increase this forward bias, does not allow the number of electrons to increase. So these whole jump this way get combined with majority charge carrier electrons here, and extra energy which they have given is emitted in the form of light. Similarly, electron jump from this to this. The electron get combined with, so this electron hole combination provide you or emit energy in the form of light. The color of light depends here on the material used for manufacture of light. Actually, you know, in case of PN junction, accident semiconductor, in case of accident semiconductor, doped semiconductor, PN junction, it is valence band, it is conduction band. There is a particular energy gap whose value may be of any order. If it is 1.8 electron volt, suppose. Now holes electron take energy, go here into conduction band. This is here donor energy state, and this is acceptor energy state. I told you that on doping, because there are both PN junction. So electron, due to this electric applied field, go into conduction band, and from there they return back to lower state. They may come here, and then here, and then here. So there may be variation in the energy of photon emitted by LED, because electron can in conduction band may go little higher, but this gap is a particular gap. Majority of photons will be of the light having photon of energy, whose energy equal to energy gap. When so that way light is emitted. The student asked me, sir, are these emitting heat radiation like bulb? Yes, very small quantity because of this one and this one. Because energy of photon of heat radiation is very much smaller than that of visible light. But so there is nearly 500 angstrom variation. If this is emitting light of 7000 angstrom, majority of photons are emitted this way. So plus minus 500 angstrom variation. So diode emit light of particular color. The photodiode emitting light of red color, yellow color, green color are manufactured and present in the market. Now we are using white LED. How this light LED? Because LED, this is called LED, but emitting white light, and you know white light is combination of all the colors. It means inside these LEDs there is a big number of LEDs emitting light of all possible colors. I hope you are getting my point. LEDs are the light emitting diode. They emit light of this particular energy gap. But there is a little variation because some more energy electron can go to higher energy state in this conduction band, from one coming from here, other coming from here, or one coming to this energy state first, and so this gap is very small. This energy of 0.01 electron volt order, less than this, and this one. So these radiation is of infrared radiation. Now LEDs which are emitting infrared radiation are available, and we have very wide application of LED in remote control. When you start your TV and change the channel, you use LED. You see LED. Technology you will learn in higher classes when you will learn electronics. If you go to that branch, if you go to mechanical branch, then you will not get it. And when you will study electronics, so you will get all these applications there. So LED has got very wide application from remote control to provide light to us. And these LEDs are, the color of light is changed by changing concentration. Gallium arsenide phosphide, X or 1 minus X. By changing the concentration of dopant, concentration arsenic and phosphorus, we can change the energy gap, and as color of light emitted will change on this concentration. For LED having energy gap 1.9 electron volt, it is gallium arsenide, high concentration of 60% is 0.6 and phosphorus 0.04. So if we dope 60% arsenic and 40% phosphorus, it is 4%. It is 4.4, sorry, 40%. So we get an LED having energy gap between valence band, conduction band of 1.9 electron volt, red LED. It will be a red LED. Pink LED, I told you, so that color emitted depend on this dopant concentration. Now, what the advantage of LEDs over incandescent bulb? Incandescent bulb means the filament bulb. it is also has advantage over fluorescent tube. Their operation voltage is small. The reverse bias, actually they can be fused on small reverse biasing. So their operation voltage of 2 or 3 volt only. Low operation voltage, while incantation will require 220 volt. They are emitting highly monochromatic light, while bulb emit all radiation, all the wavelength within the range. Large, long life, small size. Small size actually, LEDs can be prepared of a small size which are suited for or competitive, we can use in optical fibers. So small size help us there. So you can read NCERT book for this, but very important for you to understand working of LED. I told you now we are using LED light, and each LED bulb has a big number of LED connected in series, so that all possible colors are emitted. I hope you will enjoy, and in the coming video I will be telling you solar cell or solar diode, which we are using to produce electricity from sunlight, and that is a renewable source of light, very friendly, eco-friendly source of energy without any type of sound pollution, noise pollution, or other carbon emitting pollution. No pollution is there, no dust emitted. So in the coming video I will be telling you for solar cell. Thank you. Please read the book for NCERT book for this, and learn it very carefully. Thank you. Please like the video, share the video, and ask your friend to subscribe my channel. I have finished almost the whole syllabus, and I did this work so that society is benefited. Students who are not able to reach some good teachers and collect knowledge, for that it is very easy source of knowledge. Thank you.